use the Taylor series formula to find the Maclaurin series of the following function. We got function e raised to negative 5x. So Maclaurin series means it's a Taylor series which is Cn x minus center is 0. So Cn xn, n from 0 through infinity, that is the function where we find the constants Cn's as nth derivative of the function evaluated at center, which is 0, because the Maclaurin series means center 0 divided by n factorial. Okay, so let's find C1, C0, C1, C2, C3, and we might get a pattern. From there we can find this Taylor series formula. So let me make a table here. So this is for n, we have nth derivative of the function, then we evaluate the nth derivative at the center 0, then we can find the corresponding constants Cn. Okay, and by the way, Cn is given by this formula, n factorial. So n equals 0, that means nth 0th derivative, which is the function itself, e raised to negative 5x, evaluate at 0, that means plug in x equals 0 into this function, e raised to negative 5 times 0, e raised to 0, which is 1. So C naught is just 1 over 0 factorial. 0 factorial is 1, so just 1. N equals 1, 1th derivative means first derivative. Derivative of this function is e to the negative 5x times negative 5. So I'm right in the front. That's the first derivative. Evaluate at 0. So negative 5 times e raised to 0 is 1. So negative 5. So C1 is negative 5 divided by 1 factorial. N equals 2. So find its derivative. So it comes out to be e raised to negative 5x itself times negative 5 times negative 5, 25. And here e raised to 0 is 1, so just 25. And C2 is 25 divided by 2 factorial. Okay, here C1 is divided by 1 factorial, that we didn't write. Let's do more. 3 negative 125, when we find the derivative, e to the negative 5x, plug in x equals 0, negative 125. So C3 is negative 125 over 3 factorial. Looks like we have the pattern here. Okay, in the first, this is over 0 factorial, here is 1 factorial, 2 factorial, 3 factorial, and we are getting plus minus, and 1 times 5, 5 times 5, 25 times 5. So looks like in this way Cn is, we got plus minus, so plus minus, that is negative 1 raised to n when we start from 0, because negative 1 to the 0 is positive 1. So negative 1 to the n, and on the top 1 times 5 times, so that is pretty much 5 raised to n. If we take n equals 0, should be true for everything. When we take 0, okay, that is 5 raised to 0, which is 1. Okay, that's good. And that's on the bottom we got n factorial. So we can check just to make sure. Let's do it. Then from this formula, what is C3? C3 will be the negative 1 cube, 5 cube over 3 factorial. Negative 1 cube is, okay, negative 1 cube is just negative number. 5 cube is 25 over 3 factorial. Okay, that is what we have here. Negative, 5 cube is 125, sorry, that's true. So our formula that we found here is correct. Okay, so we got correct formula for Cn. Now all we have to do is just go up and plug in this formula. Okay, all we have to do is this formula plug in here. Okay, so let me write down the final answer here. Thus let me change the color. Thus this function fx, which is e raised to negative 5x, has Maclaurin series n from 0 through infinity. Cn, I mean, we found Cn here on the bottom. Okay, negative 1 to the n, 5 to the n over n factorial, and x to the n final.